Yesterday we saw map higher order functions. We saw actually how higher order functions are used on collections. Initially we started with for each. For each we saw which takes a function of some data type and returns a unit. It means it is a mutability function. If it returns a unit means it does not return any value. Unit data type means it takes all the collections, all the elements of the collections, and some we can do some modifications or write it to somewhere or update some database. We can do it for that purpose. For each could be used for that purpose. Similarly, we saw map higher order function, which takes some data type and returns some data type. It means map is used for transforming the data from one form to another form. Whenever we do ETL kind of process, map higher order function comes in handy. So you have to, a lot of the places will be using lot of map higher order functions. Again, it will be internally looping through each element of the collection and transforming each element of the collection to some form here. Similarly, we saw filter higher order function. Filter higher order function also takes a function of some data type and its return value is Boolean. We saw that if it returns true, the data or the element that is passed as a parameter, it will be collected in the destination collection. If it returns false, the parameter that is passed to the function of the higher order function will not be collected in the destination collection. So we can filter out certain data from our data set or from our collection based on the logic that we specify here. We saw these things. There are many such higher order functions. These are the commonly used higher order functions. Similarly, we will see now a reduce higher order function. Reduce higher order function. The data type is a bit complex here. I will say A dash, and A dash should be the superclass of A. The reduce is something something like this. It also takes a function. We have A dash, A, and return A dash, I will say. This is the data type of a reduce higher order function or the signature of a reduce higher order function. We'll come to this. What we will do is to understand these things, to understand in a more simple manner, I will just write it in a reduce. It takes a function and I will say it takes the same data type and returns the same data type. Just for our understanding, we'll say that it takes two parameters of the same data type and its return data type is also of the same data type. Otherwise, it looks like this. We'll come to these things as well, why there is a separate data type, different data type here. So keeping this in mind, let's see what we can do with the reduce. I'll just rewrite some nums here, collection. I will say list of 1, 2, 3, 4, 5. I will say 5, 6, 7, 8, 9. I will also say var colors. I create one more collection of string. I will say blue, then I have red, then I have green, then I have yellow. So we just created two collections here. Hi Sukesh, good morning. So we have two collections here, num collection or a collection of string. So on top of this, we used all our map higher order function. We use the filter higher order function. Similarly, we can use the reduce higher order function. So like we said, map is one-to-one transformation. We said map is a one-to-one transformation. Suppose I have 1 or 5, 6, 7, 8 and 9. I can write a function to just increment each element of a collection. I can say nums dot map. I can take first element and transform into x plus 2. Transform into x plus 2. Means I add 2 to each element of the collection. This time the destination collection is also of the same type, integer. The source collection is also of integer, the destination collection also integer. We can, but also we know that we can have totally different type. It's only about the transformation. So as we said that map is all about mapping each element to a one more element. We did a 7 here, 8, 9, 10, 11. Each element was transformed to one more element with function defined inside a map. Function defined inside a map, that is f of x. Similarly, reduce, what we can say is reduce takes all the data in a collection. It takes all the data in a collection and gives a single element. That is reduce, we can say. Some single element. The name itself specify reduce, means get a smaller data here. So get a single element from a collection of data. So that's where it is being used. So reduce can be used to do some arithmetic operation like sum. It could be used to do a product on top of the collection. On top of the collection, it means it takes all the elements of the collections and gets the sum of the elements. Takes all the elements of the collection, returns the product of all the elements of the collection. So reduce is used for that purpose. Based on what logic you specify, all the elements is taken and it will reduce it to a single element. Suppose you want to concatenate all the strings in the collection, you can use the reduce, because finally you will get a single element. So that's the use of reduce. Let's see how reduce functionality actually works. Suppose we have nums equal to list of 5, 6, 7, 8 and 9, and on that nums will call a reduce method. As I said, it is a higher order function that takes two parameters. Let's say the two parameters are a comma b, and let's say we are doing some operation. Let's say a plus b operation. If you go back to the signature, or I will say the better way is to write a function here. Yeah, I will just write this collection and I want to do the sum of all the elements of the collection. What I will do, I will define a sum function. I'll define a sum function which takes two elements and it returns a plus b. I will define a sum function. Obviously, if you see, it takes two integer of the same data type, and it also, I mean to say, it takes two parameters of the same data type, and return value is also of the same data type. I mean both all are of integer data type. First parameter is integer, second parameter is also integer, the return type is also integer, and it matches the signature here. It matches the reduced signature. First parameter, all the parameters are of the same type, and the return data type is also of the same type. All are integer here. So obviously it matches the signature of the function that could be passed to the reduced higher order function. Now we can pass to the reduce the sum function. We can pass to the reduce the sum function because the data type matches here. So it will add all the elements of the collection. Similarly, we know that we can get rid of the function definition and we can directly add the literal of the function. We can directly add the literal of the function. We have also seen that. Just replacing equal to with the arrow mark. We also seen that this is also not required. This is also not required, and we have also seen that it could be always shortcut by using underscore plus underscore. But we will stick to this syntax because we have to discuss what is A here and what is B here and how internally reduce works. We have to discuss that. So this is what we are going to keep as the signature. So this is the signature that we are using now. A comma B to A plus B. So here what is called A is called the accumulator. A is called the accumulator and B is called iterator. A is initialized to the first element of the collection. It is initialized to the first element of the collection, always. Whenever we call a reduce on nums, there will be two parameters. The first parameters will be accumulator. It will be initialized always to the first element of the collection, and this iterator will iterate from first element to the last element. It will iterate from first element to last element, but it will skip the first element. While iterating, it will skip the first element and it will go from 6 to 9. So that is how these two parameters works. And this is the logic that we are giving. After evaluating this logic, the return value will be again stored back into the accumulator. After doing A plus B or any logic that you give here, the return value of that logic will be again stored back in the accumulator. So if we say initially A is initialized to, accumulator is initialized to 5. B will, as I said, it will iterate from first element to last element. But as I said, it will skip the first element and it will be pointing to 6 here. So initially A will be 5, B will be 6. Then we will do this operation A plus B. As soon as we do this operation, we will get 11 and 11 will be again stored back into the accumulator. So A will be 11 here. Now B will iterate to 7. So this time B will be 7 here. Again these two gets added, we'll get A is equal to 18 because it will be the return value will be stored back in the accumulator. Now B will iterate to 8 and we'll get A is equal to, both will be added, we'll get 26. This time again B will be 9, so you will get A equal to 35. And finally, this accumulator will be returned from the reduce. Returned from reduce function. The accumulator value will be returned from the reduce function. I hope how the reduce function works here. Any questions related to reduce function? Any questions here on the reduce function? So if there are no questions, we will move on to, yeah, there is, okay. There is no questions, we will move on. Can we apply on only int data? No, we can apply on others as well. We can apply on the string as well. We can apply on objects as well. We can apply on the objects as well, where you want to reduce the data of collection data into a single element. We can apply anything here. The main purpose of using a reduce higher order function is making it parallelize. I mean to say making it parallel. So that is the main use of, we could have directly used the sum function. On the list we have nums dot sum. We could have done that. We could have used nums dot, probably product is there or not, I'm not sure. If at all is there, we can use a product. But we use the reduce to do that. That is because we can achieve parallelism using the reduce. That we could understand only when we learn Spark. Because in Spark also we'll be using the reduce API. First we need to understand how the distributed system works. Only then we can appreciate the parallelism done by the reduce. Otherwise, as of now, you can think that it is used for parallelism and it will reduce all the data. It will take all the data in the collection or all the elements in the collection and it will reduce to a single element. And this is the functionality how it works. We can pass a string as well. So if we pass a string, let's see what happens. If we call the same thing on colors, if we call the same thing, it will just concatenate everything because plus means concatenate. Blue, red, green, yellow, it will concatenate. But here it is a simple such function. It is just a single expression function that we are passing to the reduce, but we can pass a block of expressions, a function which has a block of expression where you want to do some logic. Even that could be passed. So I hope, Karnakar, that makes sense. Okay. It's all about making your API parallel. Sum is not a parallel API. So if you run the same reduce on a multi-node or a distributed application, sum will not benefit from that parallelism. It will not be able to do parallel processing. But reduce has the capability to do that. So but for that we need to understand how the parallel system works. First we need to understand Spark. For suppose I want to get max length of a string from colors, can I use reduce to get single element? If you want to get the max length, how do you get it? Yes, you can get it. You can use the reduce from the list. You can use the reduce. Probably everybody can try that as a thing. It is possible. Use the map and reduce and get the max. You can also get the minimum. So that's a good question. Does shall I pass it as a assignment to everybody instead of I doing that? Yes. Okay. Yeah, that would be good. Thanks for the question, Venkat. Venkat was the one who asked the question, right? Yes. Yeah, I have a collection here. The question is, anyway, I will be sending an email. The question is, I have a collection of elements of string, a collection of string. Return the element which has the highest length, max length. Return the element which has the max length. So keeping this in mind, so when we have such things, right, we yesterday we saw how we did the chaining purpose here. We saw how we did the chaining. Like I will say total, I will say colors dot map. I will give some expression here underscore dot size. I will get the size. Obviously you have to also use the size here in your case to get the, then I will say once I get the size, so it will be again a collection. It will be a collection of the sizes of each element. Then what I will do here, I will use the filter. I will take each element, I will check whether element is greater than 4. Element size, all the elements whose greater than 4. So again I will get one more collection which only contains those sizes which is greater than 4. So on top of that, again I can do a reduce and say underscore plus underscore. Only add the elements of that collection. So 5 and 6 are the two elements that we will get. If you see, if we do a val total map underscore size will give the all these things. The size of each element. Dot filter will give which are greater than 4. That is 5 and 6. 5 and 6 are greater than 4. Similarly on that we will do reduce and we can get the final result as 11. Since each function returns some collection, we can chain this kind of operation. We usually chain this kind of operation. So this is how we can use the reduce higher order function. Just add one more to this.
Yeah, Pramod, in that yesterday's exercises,
Okay.
question number 5, oh, what is that? Question number 5, can you please, uh, how, how to get that numbers, get a list of only numerical IDs that
Only.
I am not able to.
Okay. So anybody tried it? There is some extra functions that we need to use. Okay. I will come to that because some functions I haven't used till now. Probably you can
Okay,
see it tomorrow. I will cover some more functions. Probably using those functions you can figure out. Because
okay,
anyway, after doing that function, I can say how it is done. There are some more higher order
okay,
functions we will discuss. After that, I will let you. I will add
okay.
this also. Yeah, map reduce. We saw reduce now, how the reduce works. So similarly, like we saw collections like list and vector, we have a collection called a set also. What is a set collection is? Set collection is to check for the membership whether a data exists or not. That is the set collection. It is a unique, it is again based on the mathematical term set. Set is also a collection of unique numbers, distinct numbers, or distinct entities, we can say. Just like we have in sets, mathematical sets, it's the same concept that is being taken here. If I say, and the way we define it is, if I say 1, 1, 1, 2, 3, 3, 4, 4, 4, and 5, so it will, even though there are duplicates, it will have a distinct elements. That is the property of the set. So sets are usually used to check whether an element exists or not, to check for the membership, whether a membership holds good or not. You keep a set of some objects and will check whether an object exists in that set or not for the membership purpose. So usually sets are used for that purpose. So, so if you see, earlier we used like nums or colors of 0 used to give us the first element of the collection. And internally I said that dot apply method will be called. Dot apply method will be called. Similarly here, when I do set of 0, it will check whether the set 0 exists or not, because that is the functionality of the set to check for the membership. So it checks whether set exists or not here. Sorry, checks whether this element exists or not. 0. Obviously, this element does not exist, hence it returns false. And if I say 5, 5 also does not exist. If I say 4, it returns true. So again, internally,
Pramod,
yeah,
sorry to disturb. Just when you define this set, so then means it's showing that scala.collection.immutable.set.
right,
This
right,
is a immutable set. It's showing that. But
right.
same if you define the list, then it won't show. Then is that list mutable by default then?
No, no, no. List is also immutable. I need to check why it doesn't show. But both are immutable. Both are immutable.
Okay. Okay.
Yeah. Yeah, as I was saying, set of 4, it will check whether 4 exists or not. Again, it is internally set.apply method is being called. Apply method is being called. So based on different classes, apply method is defined in a different way. So it is just as I was earlier saying that there is no new concept in apply method. It is just like any other method in a class. It is just like any other method in a class. Only thing is we need not call it by name. That's all. That is called as a set apply method here. And we can also apply all the higher order functions on top of the set collections. There is nothing new. New is only is the difference here is it is a used for membership. We use it for membership. Yeah, similar to set, there is one more collection called map collection. Map is just like our hash map that we have in our Java hash map. It is the map in Scala with the capital M. Small m is all about map higher order function. With the capital M, we get a collection. So we can write a collection in this format. I will say val lookup. Usually hash maps or maps are used for some lookup here. So I will just create map. I will say yes as Scala. I will say J as Java. I will say R as Ruby. So this is how a map collection is created. This is how a map collection is created, where this is the key and this is the value. So this is our first element. First element, we have second element, we have we have a three element here. We can see how many elements we have. It shows three elements. We cannot. It will replace the value for that key. The question is, can we have duplicate keys here? It will actually replace the value for that key. And as we said, it is immutable. A new collection gets created. With that key, a new collection gets created. The original collection still remains as it is. And this is, I think we had seen this syntax earlier. The syntax we had seen earlier, the syntax was used to create a tuple of two elements. I can say var t equal to, I can write the same thing s, and I can say Scala here. So it creates actually a tuple. First element is a character, second element is a string here. So this syntax was already seen here. So we can say that map is also kind of a collection of tuples. It is a collection of tuples where, as I was saying, first element in a tuple will always be the key, second element or the rest of the element will be the value. Here also it is, this is the key and this is the value for that key. And again, lookup API, we have to specify the key and get the value. We have to specify the key and get the corresponding value. So this is how the key value. If you go back to list, we use the index to access the element of the collection. If you see the set, it was used to get the whether the element exists or not in a set. And here we are using it for getting the value for a particular key. We are passing a key and we will be returning a value for a particular key. I am speaking about the apply method. So in different collection, the apply method definition is totally different here. Internally again the apply method will be called. So there are again multiple functions on top of this. We can get only, if you want to get only the keys, we can only get the keys here. So it says key set is given here, keys is given here. I can say keys. So it will return only that key, S, J and R. If I want values, I think there should be a values also. Take is there, tails is there, values is there. You will get only the values here. So many such operations are there that we can do here. So we can compute, we can get what is the size of each element, what is the size of value of the map collection. So we have our map collection in this fashion. Suppose I want only the size of each value, scala this. So how we can do is, we can on that lookup we can do values. It is again a set, on that we can do a map here, and I can say underscore dot size. So it will return a size of only the values. I think Scala is 5, Java 4, Ruby 4. So we can use all those higher order functions. We can chain the things in this fashion. Based on what is your problem statement, we can achieve these things. So probably if anybody has any questions, probably we can take it for an assignment. So we can get, what else we can get actually? So we can also use this in the uh, for for expression. So it will be in the form of a pairs actually. We can use it in the form of a pair. I can say pair. I can say lookup. I can say yield pair dot underscore one, pair dot underscore one, because when we iterate on the lookup, which is a map collection, each element will go as a tuple here. Each element will go as a tuple. So pair is nothing but a tuple which contains first element and the second element. First element will be the key and second element will be the value. It will return a collection of only keys here. So we got S, J and R. So it will be represented in the form of a key value pair. We can directly write, instead of writing the pair, I can say key comma value, and I will just say yield key. So automatically the data inside this collection will be assigned to key and value tuple. It will be assigned to this value and tuple. It returns a tuple. We can say it will generate tuples and assign to this. So we can individually assign key here, value here. Instead of doing this and specifying underscore one, which is not so elegant way, this looks more elegant and readable. So this is also can be done. So if I want only value, I can just say value. It will give the collection of values here. So any questions still here on mapping in this fashion? Any questions here? No questions. If there are no questions, we'll move ahead. I hope the things are clear here. I hope. First we learned about the functions, then we went to higher order functions. So then we went to collections. Then we are seeing now how higher order functions are applied on top of collections. How higher order functions are applied on top of collections, because this is how the data processing will be done. So data is nothing but data sets is nothing but a collection. If you imagine it in that way, everything falls into picture. We will be applying the map transformation on top of the data collection. We will be transforming to some data format that we want, and then we can use filtering, then we use reduce to get our final results. Or we can use the combination of these higher order functions on the data set, and we can get the result that we want. So that's what we will be seeing in Spark as well. So before moving Spark, we are just getting used to Scala syntax and all the higher order functions. So if we want to add a new element to a map collection, so we can add, I will say val lookup2 equal to lookup1. I will say plus method is there. So again that plus method takes a tuple with, I will say, p key and value as Python. So this is how I add an element to a collection. But if you see, the original collection still remains the same. The original collection is not modified at all. A new collection was created, and that new collection was added to the lookup too. So we can just print the lookup once again. It is still has only 3 elements. If our lookup2 has 4 elements. Python is also being added here. So this is how we add a collection, add an element to a tuple. Plus method is there. Actually plus is a method on which we will be passing this as the parameter. Similarly, if you want to remove something, I will say val lookup3 is equal to lookup minus. There is a minus. Just specify the key that you want to remove. I will specify J here. J key value will be removed. Java, this J and Java will be removed. We are only left with S and R. So again, actual lookup will not be modified. It still remains the same because it is immutable. Only the lookup 3, if you see, it has been modified. So any questions here? Similarly, there are many such APIs. Lookup, we can just press tab. These are all methods. These are all methods. We can collect it to a string is to list is there. If we convert into a to list, it will give a list of tuples. It will return a list of tuples. S comma Scala, J comma Java, R comma Ruby. We have to array, which will become a mutable collection. To buffer, again it will become a mutable collection. Again we have take, tail is there, tails I haven't used. Sum is there. On what it will do the sum, let we need to check that. Again we have the reduce as well here, map as well here, map values is also there. Only do a map transformation on the values. So I can say lookup dot map values. Here only the values will be taken. The key remains as it is. The key remains as it is. It will operate only on the values. Reduce left, reduce right when they are used. Yeah, this you need to hold on to that for some minutes. We will discuss all these things when we learn Spark, because as I was saying, as of now you can say that reduce is something different. Reduce left. Here the data type is B, comma A, and it takes a function whose accumulator is something different, and it returns B here. So if you see the difference here, if we compare these two, the return type will be almost the same. Whatever we return from the reduce will be almost the same. But here if you see the reduce left, the return from the reduce left is nothing but B, which is totally different data type. It need not be the same data type as a collection data type. It could be return type could be totally different. So this we cannot parallelize. We cannot parallelize this. We can parallelize this. So why we cannot parallelize this? Again, we have to go and understand how the distributed application works. We have to understand how the distributed application works. So these things I will make it clear when we learn Spark. While learning Spark, we will get to know what is the advantages of reduce left and what is the advantages of reduce, what is the trade-offs we need to maintain, in which case we need to use reduce left and which case we have to use reduce. So this can parallelize multi-level. Actually we cannot parallelize this, but it has other advantage. It can return a totally different data type irrespective of the collection data type. But here it has to be the same data type as the collection data type. It has to return the same data type as the collection data type. Even though it has to be a superset, it is almost similar. The return data type should be a super data type. So super data type means if we have a collection of fruits, let's take an example. We have banana. Just for the understanding, we have something apple. These are all, suppose, a class object. Banana is one class object, apple is one class object. Suppose their super class or their parent class name is fruit. So this reduce can either return a these class object or it can return an object of its superclass. The syntax means returning a superclass. The return type has to be either as the same data class or the superclass. But if we see here, it is totally different. Irrespective of what the collection is, of which data type the collection is, we can totally return any data type. And that will make you not to achieve parallelism. We can get that, but we cannot achieve parallelism. We will see that. We'll see those things in the Apache Spark. So as I was saying, map values also there is a API. So this map as map actually works on the whole element. Map always takes each element. Map values is available on map collection because map collection keeps the data in the form of a key value pairs. And as a result, we have a API called map values where it only works on the values. So whatever underscore we are giving here, it is actually the value, On that value, I can just say size of that value. So it will return a map collection again where the key remains the same and the value is modified from string to integer, and only the value is modified. So all these APIs are available. Again, map values is a higher order function. It is a higher order function which takes each element and only gives that element. It only works on the, I think map keys is there. There is no such thing as map keys. So map will only work. So if you want the same result, but using the map, how we can do that? Using the map. So each element will give a tuple. Each element will give a tuple here on the map. Each underscore is a tuple. On that tuple, the second element is nothing but a string. So we got the string now. Now we can do the size. But here it will return a list of this. It will not return a tuple, but it will return a list. So that we can, it is just returns a list of 5, 4 and 4. So if you want to achieve the same thing as the previous one, how we can achieve? I can achieve in this fashion. Again, x dot underscore 1 remains as it is. X dot underscore 2 dot underscore size will do. Underscore 1 remains as it is, and the other thing we are keeping it as a, or again it will return a tuple of list here. It will return a collection list here with the tuple. Yeah, map. So how do we achieve? No, it has achieved the correct one. So we achieved the same thing here. Yeah, because it's a map collection, right? That's right. I was wrong. I hope these examples probably I should have given as an assignment. I hope the things are clear how we can do these things. How these various APIs could be used. So suppose if you want to use some API and if you have any questions on that API, please do let me know. I will also try because I haven't tried all the APIs. I haven't tried all the APIs. If you face any questions on using certain APIs and if you want to know, just let me know. I will also try it and I will try to get the answer if you are stuck in some other API. So any questions here on map collections or map higher order functions or map values higher order functions? Any questions? No questions. Okay, if there are no questions, we will move on to certain more things here. What do we have next? Yeah, we have seen all these things, list inside a list. list inside a list we have seen. We can have also list because it's just a collection of lists actually. All these things are possible. There are some more examples, you can try it out. If you face any problem, please do let me know. All these are simple examples. So there is one more method we want to see, that is the cons method. It is called the cons method. The cons method is represented in this fashion. If you see, I will just see colors is a collection, colors dot colon colon, sorry, colors dot, just press. You will see that these are all operators. This is an, I mean to say methods. This is a method. These are, all these symbols are methods in Scala. So from this we will see what is a cons method. We will see this method, and this method is called cons method. So why we will be seeing that const method? Because there is some property associated with that const method. Otherwise, it is just a method to add an element to the head of the collection. It is just a method to add an element to the head of the collection. But there is some new property that is associated with that. Also, it could be used with pattern matching. Whenever we do pattern matching on collections, this operator can also be, or this method could also be used in the pattern matching. So let's see what is the speciality of that const method. So we saw that we created nums collection equal to list of, I said 5, 6, 7, 8, 9. We had a list here. So this list could also be created in another way. It could be created like, we can say 5 colon colon 6 colon colon 7 colon colon 8 colon colon 9, and at the end we need to specify a empty collection in this fashion, or we can say empty collection in this fashion. So this will also create a collection here, same as above collection. It will also create a collection same as the, so how did it create actually? How an element that adds, how a method that adds an element to the head of the collection created a collection, and the new property associated with that is not a big deal here. When we say val x equal to 10, and when we say val y equal to 20, and when we say val z equal to x plus y, what we mean by x plus y here? It means that plus is associated with the object on its left hand side. It means plus is associated. There exists a plus method on integer. There exists a plus method on integer, and that plus method is associated with the object on its left hand side. In a similar way, there is a rule. You can make it as a note, a generic rule, that any method that ends with a colon, it will be associated with the object on its right hand side. It will be associated on the object on its right hand side. So on the right hand side, we need to have an object that has this method. On the right hand side of this method, we should have an object that has this method. So it will be always associated on the right hand side. Any method that ends with colon, it will be associated on the right hand side. That's the reason we are giving an empty list or a list on the right hand side. Because whatever we give here, that should have this method, because this will be associated on the object on its right hand side. So internally the evaluation happens from the right to left. So internally how it happens? It will have list, empty list. On that list we will be calling colon method. On that list we'll be calling colon method, and we'll be passing 9 as the parameter to that, and we'll get a, if you see, it also holds true that it adds an element to the head of the collection. Earlier our collection was empty collection. 9 element was added to the head of the collection. Element 9 was added to the head of the collection. Similarly, after we have a collection with one element, again on that the colon colon method will be called, and 8 will be passed as a parameter, and 8 will be now added to the head of the collection. So 8 will come first. Similarly, it will go on like this. Colon colon method will be called, will pass 7. Again colon colon method will be called, will pass 6. Again colon colon method will be called, will pass 5. So we'll get the final result. So internally this is how it works. So why it works in this fashion from right to left? Because there is a generic rule that any method that ends with the colon will be associated with the object on its right hand side. So internally this is how it works. So if you want to add a new element, nums equal to, and I want to add it to the head, so I can say 10 colon colon nums, because on the right hand side we need to have a collection, because it is associated with the object on the right hand side. Okay, that is because we have to specify nums1 something here. So this is how we have added a collection here, added a new element to a collection. Any questions here? Till here, any questions on the const method, the way the const method works? Similarly, there are, if you want to add an element to the end of the list, so we can also add such thing using a symbol method. I will say nums3 equal to nums colon plus. Again, colon plus is a method which adds an element to the end of the list. I will say 11 here. But this time if you see, the method did not end with the colon. The method did not end with the colon. Hence this method will be associated with the object on its right hand side as usual, which is a traditional way. Only the methods that ends with the colon, that will be associated with the object on the right hand side. So this is how it works. So any questions on const method, any questions on higher order functions, list or map collection or vector collection, or how higher order functions works? I hope the things are clear here. The things are clear. Yeah, there are some more. We already have seen the filter higher order function. It takes each element, it checks whether it is greater than 18. So it will give all the elements which are greater than 18. It will return a collection which is greater than 18. Similarly, there is a partition method. There is a partition method. What it does is it will not only return for whichever value we get the true return value, it also returns for whichever value we get the false return value. So here it will return both all the elements which are less than 3 and all the elements which are greater than or equal to 3. Both the things will be returned by the partition higher order function. But it will return both as a separate collection and the first as a tuple actually. Tuple of separate collection. So here I have nums here. Nums is nothing but 5, 6, 7, 8, 9. On the nums, I can say nums dot partition, nums dot partitions, to which I can pass some logic greater than 7. Greater than 7. So all the elements which are greater than 7, like 8 and 9, will be in one collection, and all the elements which are less than or equal to 7, that will be returned as a separate collection. 5, 6, 7 will be returned as a separate collection. So if you see 8 and 9 has been returned as one collection, this has been returned as a separate collection. So we can also assign directly in this fashion. I can say val pair, I can say pair list. Pair list will be this, or I can say x comma y. I can assign in this fashion also. I can assign in this fashion also. So because this partition returns a tuple, first of element of the tuple will be assigned to this, second element of the tuple will be assigned to this. So x will be this list, y will be the other list. So I think in Python also we try to use the same syntax. So I hope you got the what is a partition higher order function. Any questions? Uh, are we on the same page here, or any questions? It would be very helpful. Even for others it would be helpful. No questions. Yeah, keeping these in mind, we'll move on to the next thing. There is also a sort by higher order function. There is a sort by higher order function to which we can pass, again it is a, as I said, it's a higher order function. We'll pass a function to that, and whatever return we get from that function, whatever the value is returned from that function, using that function the sorting will be done. After evaluating this expression, whatever value we get, using that the sorting will be done here. So if I have colors here, in this fashion, I can define a function like size sort, which takes a string, or I can just not say sort here, just say length, define length is equal to this, or I will say yes dot size. So this I can pass to the sort by. I can pass it to the sortBy. So whatever this function returns, based on that return value, actual sorting will be done. Again, sortBy is a higher order function. So if you see, red came first because we are sorting it by the size of the string. So this came first, then this, then this. Yes, it will be again a new collection. Again it will be a new collection. If you see colors, it is still blue, red, green, yellow. Because the list is immutable. So a new collection was created and it was assigned to this compiler generated this. So otherwise I have to sorted color, I can say. Sorted colors equal to this. Val sorted colors equal to this. So a sorted colors collection will contain all the sorted list. Possibly you can use this also to solve the problem, but I wouldn't recommend doing this. The problem asked by Venkat, we can use this as well. But try to do other thing using the reduce. This could also be done, but try to use the reduce there. So how can we do it? How can we solve the same problem using the sort by? Can we try that out? How can we achieve the same thing the question asked by get the element with the max size get the element by the max size. So how can we do this? Any guess? I think it's without using max method. Yeah, max method could also be used using sort by. Using sort by. Using sort by, how can we achieve the same thing? Get the element with the max size. So one way is that's what, if we see here sort by, we can, as I said, length is not at all required. This function definition is not at all required. We can directly say underscore dot size. So it will give a sorted collection here. So if I want to, right, last element will be the max. What we'll do is I will just say sort it in the descending order. A negative sign is just required to sort in the descending order. So we'll get a descending this. So I will just take dot take 0 or just say 0th element. Just take the 0th element. So it should give what happened. Type mismatch, required ordered. One second. So I can say sorted. So it should have given it right, yellow. So this way also we got it. Underscore 0. So why underscore? There is something different. Scala math ordering required. It returns a list and rest of this should be fine. Let me try what he is asking. Underscore 0. I don't think so. It should. Yeah, it should not work. Underscore 0 it should not. But the other thing should have worked. It says required Scala math ordering of int. Okay, okay, I got it. We will look into it later. Okay, because if you see, there is one more, the currying, actually it is a currying that is making it not to give that. We will look into that when we learn implicits. When we learn implicits, this error, why we got this error, we will get to know that. But first we need to understand what is implicits. So this is also a way to get. Yeah, we will get to know why it will happen. We'll get to know why will happen. So this is how we are doing. This is the way we can get the first element, but I would suggest to try with the reduce as well. Reduce as well. So we can also do the other way also. I'm just trying to give other ways here. Just try using the dot size should give the all the elements. On that we may have a max. As Karunakar suggested, there is a max here. But again, it will only give the size. We will won't get the actual string here. We will get 6 as the size here. So max will get the size and not the element. Many other ways to do that. There is some other way also to do that. We can do that. Just try with the reduce as well. So these are the all higher order functions that are available on collections. What do we have next? So as I said, this will add an element to the end of the collection. Take right, drop right, we have already seen these things. Okay, I was supposed to collect. This always gets pending. This always gets pending. Somehow I need to make it available. Anyway, this is called, we'll see this later. This is associated with the partial function. We'll see this later. Just remind me in next day or on Monday to discuss on collect, because I usually keep forgetting. Just remind me on how to, what is this collect. This is actually internally it is a partial function. There is a concept called partial function. So we have to discuss that concept. It is not related to partially applied function. We have seen already partially applied function where we hold back certain parameters. But this is called as a partial function. So we'll look into this partial function. Just remind me on Monday because I keep on forgetting that. Similarly, we have a flat map here. What is a flat map? That we'll see as a API. Again, it is a higher order function. Suppose I have a collection in this fashion. I have milk, tea. This is the first element. I have black, coffee. This is the second element. This is the first element and this is the second element. But I want the result as milk as the first element, tea as the second element, black as the third element, and coffee as the fourth element. So this is how I want it. So how can we achieve such thing? How can we achieve such thing? So here we are having two elements, but we want a result as 4-element collection. 4 elements. Here we are only having 2 elements. So we can use, if you see, suppose we have val s equal to, we have a string in this fashion, t comma milk comma t. So I can split this string. I can split this string. We have already seen the split API on a string. So it will split on whatever you give as the splitter. I'm giving comma as the splitter, so it will split on comma and it will return a array collection where this will be the first element, will be the second element. So we got 2 elements from one element. From a single element, we got 2 elements. We separated these 2 elements. So we always can use a split method to achieve our problem. To achieve the solution to problem, I can use somewhere in the split again. So what I will do here is, I will just say val string array equal to, I will take, did I define that collection? I will say val s list equal to, I will say list of milk tea, first element, and the second element will be black coffee. So what we'll do here is now sl dot, I have to do split on each element. I have to do split on each element to separate each element. I have to do a split on this. I have to do a split on this. So obviously I can use a map transformation to transform my data from a string to something else. I will take each element, I will do a split on this. The map higher order function takes each element and does a split on this. So what it will return? Split, we know that it returns an array. So for each string, it returns an array. So we'll transform our element from a list of string to a list of array of string. It will transform from a list of string to a list of array of string because each element will return an array. We saw that if we do a split on that S, it returns an array. And we are doing it on each element return the array. But this is not what we want. We want it is as a separate elements and not a array of elements. So we don't want array of string, we just want list of string. So what we can do on this is there is a method called flatten. There is a method called flatten. It will just flatten or unnest the nested structure. If we have a nested structure, it will unnest it. So that's what we are unnesting. So we got our final result. Whatever we wanted to solve, we got it. So here, instead of doing map and then doing flatten, there is a API called flatMap itself. There is a API called flatMap. So flatMap is nothing but it will map the transformation and unnest some nested structure. It will unnest the nested structure after doing the map transformation. That's what we call as a flatMap. If you see here, earlier our collection had only 2 elements. After doing flatMap, our collection has more than 2 elements. If you compare it with map and filter, we can say that map has always the same number of collection. If the destination has n collection, if the source has n elements in the collection, the destination will also have n element in the collection. If we say filter, if the source has n element in the collection, the destination have less than n element in the collection. Less than or equal to n element in the collection, because for everything we can return a false. The condition may not hold good for all the elements, so the number of elements will be always less than n, right? It will be always less than or equal to n. If you take flat map, we have always increased the number of elements, so obviously it will be greater than or equal to n. It will be greater than or equal to n. Similarly, we have reduced the number of elements in reduce will be, it will be reduced to a single element from a, if it has n to single element. So the transformation happens in this format. So any questions still here? So there are some more reduce kind of a function here. There are some more reduce kind of a function. The reason I'm telling reduce kind of a function is because it operates on all the elements of the collection and it returns a single element. So let's say we are having a collection of booleans. We are having a collection of, validation is a collection of booleans. It has true, true, false, true, 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 something. It's just a collection of booleans. So there are functions like for all, higher order function. For all is a higher order function which takes an element, it checks whether all the element in the collection is true. It checks whether all the elements in the collection is true. Obviously, all the elements in the collections are not true because there is one false element. So for all can be used for that. So this function can be used to solve the problem. The problem fifth solution, fifth question asked by Sandeep. So probably this API can be used. This API can be used, but along with some other API. Along with some other API. This API can take a string and it can check for all the characters in the string. We can use for all, and it can take a string as the input, and each character, because it checks for all the characters. It takes some elements, and for all means all the characters should be something. Here we are checking true, there we can check for something else, a numerical value. So for all can be used to solve that problem. So just try it out. If not, we can discuss it tomorrow. We can do that. Would that be fine? Yeah. Any questions here, Sandeep or anybody? No questions. So probably you can use these APIs, right? For I hope the for all concept was clear. Uh, what was that, Sandeep? So do you want me to repeat again on this for all higher order function? Okay, it was no questions. Okay, okay. I mean, fine. Yeah, for all, as I said, it checks whether each element is true. Obviously, we have false in one of our case. It will return false. It will return false. Similarly, it could be used to check whether each character in the string is a numerical. If it is, then it will return true. Otherwise, it will return false. So we can use these things. Similarly, there is again one more higher order function which takes and checks whether a false exists in the collection. A particular element exists in the collection. So exist higher order function is being used here. Obviously there exists a false higher order, false in the collection. It returns true. It returns true. And here it returns false. We are calling this R as a reduce kind of a function. That is because it operated on all the elements of the collection and it just returned a single element. Just returned a single element. That's the reason we are calling it as a reduce kind of a function. So as asked by Karunakar, we can also apply it on the strings. We can also apply it on the integers as well. So we have only seen part of the reduce function. We have only discussed which is relevant to Scala, the reduce function. We have to discuss still some more things about its parallelism, some more things about what kind of operations can be performed. We cannot perform all kind of operations here. We can only perform like plus operation, we can only perform minus operation, we can perform max operation, min operation, uh, subtract operation. Lot of operations we cannot perform. It is restricted to only certain operations in the reduce. We haven't covered all those things. Those things will be much clear when we discuss it with Spark. When we discuss it with Spark. So keeping these things in mind, we will move to pattern matching with collections. We have already seen how the pattern matching works on the simple data types, and that was the simplest case where we used to pass data to the map expression, and we used to write case expressions, and we used to do value binding, and we also did the underscore, which was the default case. But we'll also see how it works on the collections. How it works on the collections. So this is a simple case actually. I will define a status function instead of statuses. Let's have a status itself. I'm having a collection status here. I'm having a status collection. So here what I'm doing here is we are just doing a recap on our previous thing. We are doing a recap on the previous thing because we are not passing the whole collection here. We are just passing an element of the collection which is similar to passing a single element to a match expression. So what we passed, as we said, that this expression will be evaluated first. After evaluating that expression, whatever value we get, that value will be passed to the match expression. What value we get from here? We get 500 as the value. Head is 500. So 500 will be passed to this match block. And we have a value binding here. That value will be binded to X, and we have this condition. If X is less than 500, say OK. Since this pattern does not match, we know that the whole pattern has to match because 500 is not less than 500. 500 is equal to 500. Obviously this pattern does not match. It will move to the next pattern. So next pattern is nothing but it's a underscore, meaning it can take anything. If nothing matches, it is like a default case. So obviously we are getting an error here. We are obviously getting an error. So now this is a recap of the earlier case. What we'll do is we will directly pass the status itself. Instead of passing the head, we'll directly pass the, and I will say case, and I will say list 400, 500, and I will say error not found, whatever you can write it, not found, and critical error. Here I will say case list, I will say 500, 404. I did a mistake there. The first statement I could say critical error and not found. So I can directly use the collection itself for pattern matching. This we cannot do in the switch cases in other programming languages, but we can do these things in the case itself, in the list itself. Sorry, we can do this in the match expression in Scala. So what does this define? What does this define? This defines saying that I will match the expression if it is a list collection of exactly two elements, and the first element has to be 400 and the second element has to be 500. That's what this case expression defines. I will match the expression only if whatever is passed to the match block is a list collection of exactly two elements. First element has to be 400, second element has to be 500. If that matches, these expressions will be evaluated, and that evaluated value will be returned to the from the match block. It will be returned from the match block and assigned to this. Obviously this does not match. Obviously this matches because we are passing the same thing. It matches here. Any questions here on how This pattern matching is working. Any questions on pattern matching? No questions. So we can move ahead with some more examples on pattern matching. We can also do value binding. We can also do value binding here. So we have discussed value binding. I can also do value binding. I can say X here, uh, not this one. And I can just say, I can get the value of this using the string interpolation. Using string interpolation, I can get the value of X. Similarly, I can say case list. I can say 500 comma X. I can say the same thing. I use the string interpolation. I will say critical error and $X. So what does this mean here? What does this mean here? So what this expression will define? This expression defines that I will match the expression. I will match the expression if it is a list collection with exactly two elements and the second element has to be 500. And the second element has to be 500, then the first element will be binded to X. 500 will be binded to X if at all it matches. If at all it matches. Obviously it does not match, it will go here. And what does this say? It says that I will match an expression with exactly two element collection and the first element has to be 500. X will be binded to 404. X will be binded to 404. So if you see, we are returning X and X value is 404. So this is how we use value binding inside a collection. Value binding inside a collection. So how does this work actually? How does this pattern matching works on a collection? So to just give a gist on that, we can say that we saw we have a collection list. We said val nums equal to, we said, list of, let's say, 5 comma 6 comma 7 comma 8 comma 9. So what actually happens here is internally we know that internally actually list dot apply method is called. Again apply method comes into picture here. Internally apply method is called. So which takes all the elements of the collections and returns an object. It returns a object. Nums could be, I can say nums equal to list dot apply and I will say 5 comma 6 comma 7 comma 8 comma 9. So internally when I say list of 500 comma 400, internally apply method is called. So as I said, apply method could be any method. It can take a single parameter method, it could be a two parameter method, or it can take variable number of arguments method. This apply method takes variable number of arguments. So that is defined inside the list. It is defined, this method is defined inside the list. So we can have a simple rule here just for our understanding or just for our understanding and not to take it for granted. So apply method, what we can say about apply method here is it takes elements or member fields or elements or parameters. It takes parameters or I can say members, and returns an object. So that's what happening here, right? It returned a nums list object. It took all these parameters, or it took all these members and returned an object. So we can partially generalize that apply method. We can generalize a bit of an apply method. But apply method can also do many other things as well. This is one of the way we can take it. So as there is an apply method, there is a unapply method also. So there is an unapply method. It is a reverse of that. It takes an object and returns elements or parameters or the members, and returns members, we can say. So this is a unapply method, how it works. So internally what happens here is when we do a pattern matching, this unapply method is called. It returns a unapply method is called, to which this object is being passed as a parameter. We know that unapply method takes an object and returns all the fields or all the members or all the parameters. So the status object is being passed to the unapply method here in this. Whenever we do case expression on a collection, automatically unapply method is called. To that unapply method, status is passed as an argument and it returns x and both the parameters. It returns both the parameters or both the elements of the collection. 500 and 400 will be returned. 500 is this, and it will, in this case it will not match. It will check whether it is a 500 and it will return. So this matching does not happen. The matching does not happen, hence this pattern does not match. When it returns, right, that pattern does not match. Hence when it returns, the matching does not happen, hence it does not do this. And when this here also, next it will go here, the unapply method will be called, to which this status object will be passed as a parameter, and it will return those fields or these elements. 500 is matched here and x will be assigned to 404. X will be assigned to 404. So this is how that pattern matching happens. It happens because of the unapply method. Where is it? So it happens because of the unapply method. It takes internally some object. So if you want to know more about the unapply method, so I have shared a book called Neophyte's Guide to Scala. So it has, there is a book called Neophyte's Guide to Scala. So the first itself is the same thing. Extracting sequence, first two things gives the how internal, but it is not, it's okay that you don't have to go into underneath this unapply sequence. For collections it is sequence. For normal objects, if for user defined objects it is unapply. So unapply sequence is for collection. There is unapply method for user defined objects. So it returns an option of this. We will see what is an option later. So till then, just hold on to that. Till then we know what is an option, because we have to still discuss what is an option. It is also called as monadic collections. We'll discuss this, then we can understand how unapply method works and how using that unapply method actual pattern matching works. Pattern matching works only because of the unapply method. It will not work otherwise. And that unapply sequence is already defined inside the list internally by the Scala. The unapply sequence is already defined, hence it works. So you cannot randomly do pattern matching on anything. We can do pattern matching only on the data or on the objects which has an unapply method, which has a unapply method. Those things also we'll see when we learn about objects, when we learn about object-oriented thing of Scala, then we'll see how we can define our own objects, our own class, and how we can use unapply method with our classes. I hope till here it was clear. To know more about unapply method, just you can go through it's in this case. Here also we have already discussed what is this colon method. So it will be easy to follow up on this, what actually the unapply method, what actually this pattern matching does. So probably we'll have uh, some more, I will try to come up with more example assignments on pattern matching case and collections. I will come up with more such questions, so assignments. I hope things are clear here and we can move on to the next. So we'll wind up here. It's already 9. We'll wind up here and we'll probably from Monday we are a bit left with some more things. These things are not required. Streams is we can discuss. Then we have options we'll get later, monadic collections. We'll discuss a bit on options. We'll discuss a bit on other monadic collections. Then we have object-oriented stuff. From Monday, we are still more, probably 2 or 3 more classes will be there on Scala. Once that is done, we will be going to Spark. Any questions here? Till here, any questions? If you have any